Hey there, Kipsters. We're looking at objective 1C.6, scientific notation. This is something that scientists use a lot when they are looking at really big numbers or really small numbers. So definitely if you're thinking about engineering or the sciences, numbers or types of numbers you'll see a lot of. So we're going to look at two skills. First, how you would convert a number from scientific notation to a number in standard notation. And so the two numbers, or four numbers you see here, are numbers written in scientific notation, and you're going to convert them to numbers in standard notation. That means a number that looks like any other number you've seen before. I'm going to show you an example with A and B. So if I look at 3.15 times 10 to the 6th, I know that means 3 and 1500ths times 10 times 10 times 10 times 10 times 10, 6 times. There's a trick to do this though, which is really, you just need to move the decimal 6 places. Since it's positive 6, I know that the number is going to get bigger. And so I'm going to start with 3.15, and then move my decimal 6 places to the right, since the number gets bigger. 2, 3, 4, 5, 6. So I moved it 6 places, 1, 2, 3, 4, 5, 6. And there's my new decimal. I fill the rest with zeros. Written as a number in standard notation, this is really 3, 1, 5, 0, 0, 0, 0. You can put commas there and there. This really says 3,150,000. I'm going to show you an example with a negative exponent, just so you can see what that would look like too. If I have 2.4 times 10 to the negative 5th, my trick is I'm just going to move the decimal 5 places. But since it's the negative 5th, that really means divided by 10, divided by 10, divided by 10, divided by 10. And the trick is to move the decimal 5 places to the left, since the number is going to get smaller. So if I start with 2.4, I'm going to move my decimal 1, 2, 3, 4, 5 places to the left, and that's where it ends up, and fill the rest with zeros. I'll rewrite my number as 0.00024. Let's see, that would be tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So you have 24 millionths. And just for good measure, I'll add the 0 before the decimal, since that's usually what you're used to seeing. And that would be the simplified number, or that would be the number written in standard notation. I want you to try C and D now. Stop the video here, press play when you have your answers. Okay, you've tried, so let's check your answers for each of these. If I have 1.134 times 10 to the negative 6th, I should have started with 1.134, and I'm going to need to move my decimal 6 places to the left, since it's a negative exponent. I move it 1, 2, 3, 4, 5, 6 places. I fill the rest with zeros. You can see there's 5 zeros there, and my new number is 0, 0, 0, 0, 0, 1, 1, 3, 4. So a really small number, like, I don't know, maybe the size of a molecule in science. Just for good measure, you add the 0 before the decimal, and that should have been your answer. Let's see, you have tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, billionths. This is 1,134 billionths. That should have been your answer. If you fixed completed D, to check your answer is 4.9 times 10 to the 4th. You had to move your decimal 4 places to the right, since it was a positive exponent. If you move it 4 places to the right, there's your new decimal. You add 3 zeros, and your answer should have been, let's see, 49000, 49,000. Give yourself a check if you got it right. Now, before we move to slide 2, where we're going to be going from standard notation to scientific notation, going the opposite direction, I want you to see something about all 4 of these numbers. which is that the first number is always between 1 and 10. 3.15, 3 and 1500ths is between 1 and 10. 2.4, 2 and 400ths is between 1 and 10. 1.134 is between 1 and 10. And 4.9 is between 1 and 10. That's going to be really important when we go the opposite direction. So I want to rewrite each of these numbers in scientific notation. And so in order to do that, the